Good morning, everyone. I'm Gautam Chouhan. Today, I'm going to present on the topic tree graph structure data, which is fundamental concept in computer graphics and visualization. This topic helps us understand how complex relationship and graphic scenes are managed efficiently using hierarchical and network structure. In this presentation, we will go through a number of important areas like an introduction to structure data in graphics, tree graphic structure and their types, graph structure and their characteristics, scene graphs, real life application of these structures, common algorithms used, visual techniques, and finally a summary followed by hands on activities, further learning resources. The main objective of today's session are to understand how tree and graph structure are used in computer graphics, to explore real world application of this structure in visualization, to learn about essential algorithms and their use cases, to analyze example of structured data and to prepare for using this concept practically in graphical tasks. In computer graphics, scenes often involve complex relationships. For example, objects within objects or movement dependencies. Tree and graph structure help model this relationship efficiently. They provide ways to improve scenes organization, enable modular rendering, and manage hierarchical data like animation or object group. Next, we have tree structure in graphics. Tree structure are hierarchical and acyclical. They are ideal when you have a strict parent-child relationship. Examples include binary trees, quadtrees, octrees, bounding volume hierarchies. These are often used in special partitioning, collision detection, and animation skeleton. For example, quadtrees are used to divide 2D space for rendering and visibilities calculation. Here we have an example of quadtree. Next we have graph and graph structure in graphics. Graphs, on the other hand, consist of nodes and edges. They can be direct or undirected, cyclic or acyclic. They represent more flexible and non-hierarchical relationships. They represent in this graphics they are used in mesh connectivities, navigation systems, and shader dependency resolutions. Think of a directed graph representing movement paths or object dependency in a simulation. Here we have an example of directed graph. Scenes graph. A scene graph is a specialized tree where each node represents a graphical elements like models, transformation, materials, or lighting. These are crucial for rendering as they allow transformation inheritance, meaning child nodes inherit transformation like rotation or scale from their parent. They are traversed for rendering or event propagation in a structured way. Then we have application in graphics. Trees and graph structure are applied in uh, gra- uh, several real worlds graphic tasks. Rendering optimization using BVH, spatial partitioning using quadtrees or octrees, skeletal animation where bones form a tree, pathfinding using graphics and games, and building in interactive visualization tools for UI and analytics. Then we have the algorithms of trees and graphs. Some key algorithms. It includes depth first search and breadth first search. It is also known as DFS BFS for scene traversal. A star algorithm for pathfinding in 2D and 3D environments. Graph coloring for resource allocation and scheduling. This algorithm enables efficient rendering, animation, and interactivity. Then next we have visualization techniques. To visually understand and debug a structured data, we use tree maps to display hierarchical data, force directed layouts for graph structure, interactive exploration tools in 3D environment, and a real world a real-time graph visualization and simulation on network systems. The next way, uh, to summarize, tree and graph data structure are crucial in organizing and rendering complex scenes. They provide performance, benefits, and a logical structure. Algorithms enhance their utility for tasks like animation, rendering, and navigations. These concepts are foundational to any computer graphics pipeline. And then mm, next we have hands-on exercise. Some exercise we can perform to so, activities to perform to get some experience. Draw a quad tree for 2D scene layout. We have seen a quad tree in our fifth or sixth slide. This is an example of quad tree, and where we have found. And we can create another exercise is create a basic scene graph for a video game. Each video game contains some graphs, and a scene graph is also used in video games. So we have to create a basic scene graph for a video game. Then next we have simulate BFS traversal on a mesh graph. Try to apply a breadth first search on a mesh graph. It is crucial, but it is a good exercise to get some experience. Then next we have implement a simple A star algorithm for grid navigation. This algorithm is amazing for the navigation. Then next we have demonstration and practicals. For demonstrations, I will show you a scene graph traversal using pseudocode for OpenGL. In the future, we can use will use a graph visualization tool to explore node connectivity or other algorithm working on it. Pathfinding animation on a mesh or grid. Those are the things we can do in our future. It is for practical purpose. I can show you on the slides. The next, these are the resources for further study. This presentation is not enough for learning everything about trees and graph structure data. There are more things to learn to go more deeper. For those who want to go more deeper, have to learn from different websites or documentations. Here we have a computer graphics principle and practice by Folly it AI. OpenGL documentation on scenes and graph rendering, interactive computer graphics by Edward Angel, and online resources such as MIT OCW on data structure in graphics. These resources are for them who want to go deeper in these topics to learn more about them. If they want, they can use this resource. I have done. Next slide, please. Okay, here are the references which are used for creating this presentation. A GFG scene graph in computer graphics. This is amazing site for exploring about scene and graph in computer graphics. Next, we have OpenGL documentation, as we talked before about this. This is an amazing documentation for learning more about this data structure. The next we have IEEE Explore Graphics Research. Now, here we can explore more about this data structure, and I think that website is also amazing for learning about this. And next, um, and question all that brings us to the end. Hmm. That brings us to the end. Thank you so much for your attention. If you have any question or would you like to clarification, feel free to ask. Comment on this video. I hope this gave a clear understanding of tree and graph structure, data and graphics. Comment on this video. I will try to answer all the comments. Thank you so much.